Look at the room you are sitting in right now. The walls, the ceiling, the distance to the door, all of it feels like a fixed, permanent unit of reality. By the end of this episode, that feeling will not survive. Here is the shape of what is coming. Your room sits inside a city. The city sits inside a country. The country sits on a planet. The planet orbits inside a solar system. The solar system is one mote inside a galaxy. And the galaxy is one smudge inside a universe so large that the number describing it stops that whole ladder, one confirmed measurement at a time, and by the last run, the room you started in will not be visible on any scale we are using. Step 1 costs nothing. Your room, your street, your city, your country. You have already lived at this scale your entire life. It is the scale of your job, your relationships, your ordinary Tuesday, the scale small enough that a delayed train or a bad conversation can feel like the most important event of the week. Nothing about that scale prepares you for what a planet actually looks like from outside itself. Step 2 is the planet. Earth has an equatorial diameter of about 7,926 miles and a circumference of roughly 24,901 miles. Locally, that is enormous. Entire lifetimes get spent trying to see a fraction of it. But pull back far enough to see the moon as well, and the picture changes fast. The moon sits an average of 238,855 miles from Earth, and NASA's own comparison for that gap is blunt. About 30 Earth-sized planets could be lined up side by side in the empty space between here and the moon. In the gap next door. Now pull back until the sun enters the frame, and hold on to this next image, because it resets your sense of scale for everything that follows. NASA states the comparison plainly. If the sun were scaled down to the height of a typical front door, Earth, at that same scale, would be about the size of a nickel. Not a beach ball leaning against the doorframe. A nickel. Your entire planet, every ocean, every mountain range, every person who has ever lived, compressed to coin-sized, standing next to a single door-sized stops behaving the way your instincts expect. The distance from the sun to the Earth defines a unit astronomers actually use, called an astronomical unit, about 93 million miles. On that scale, Neptune, the last major planet, orbits at roughly 30 astronomical units out, and that is where most people mentally close the book on the solar system. It does not close there. The Kuiper belt begins at Neptune's orbit and runs out to about 50 astronomical units, a wide ring of icy debris that includes Pluto, and beyond the main ring, a scattering 1,000 astronomical units. Only past that does the solar system's true edge begin. Scientists place it at the Oort Cloud, an enormous shell of icy debris whose inner boundary starts around that same 1,000 astronomical unit mark, and whose outer edge is estimated at roughly 100,000 astronomical units out. Here is where it gets uncomfortable. Voyager 1, the most distant object humanity has ever built, launched in September 1977 and crossed into interstellar space on August 25, 2012. It is still climbing outward today, and this is not a historical fact, it is happening on a schedule you can check right now. On November 18, 2026, NASA expects Voyager 1 to reach a distance of just over 16 billion miles from Earth, the exact distance light itself covers in 24 hours. Astronomers call that a light day. No object we have ever built has reached one light day from home before. This fall, for the first time in the history of our species, one will. And even then, it will not be out. Probe on a similar outbound path will still need about 300 more years just to reach the inner edge of the Oort Cloud, and possibly another 30,000 years after that to fully clear it. The single farthest thing humanity has ever built will spend this November becoming the first man-made object to sit a full light day away, and by the true measure of our own solar system, it will have barely cleared the driveway. Sit with that for a moment before the next step, because it only gets less intuitive from here. If the actual edge of our own solar neighborhood is that far beyond our most capable machine, what is waiting once we zoom out past the sun entirely? Step 4 is the galaxy, and the first thing it costs you is the idea that we sit anywhere near the middle of it. The sun is located about 28,000 light-years from the galactic center, out on a small partial arm called the Orion Arm, or Orion Spur, sitting between the much larger Sagittarius and Perseus Arms, a suburb of the Milky Way rather than its downtown. And the Milky Way itself is home to somewhere between 100 billion and 400 billion stars, spanning roughly 100,000 light-years across. A single light-year is simply the distance light itself covers in one full year. second, the fastest anything can travel. Multiply that speed by 100,000 years just to cross from one edge of our galaxy to the other. Our entire solar system, Sun, every planet, the Oort Cloud, and Voyager included, is a single point of light out on the suburban edge of that structure. Not a large point. Not a notable one. One point among 100 billion to 400 billion others, on one ordinary arm of one ordinary spiral galaxy. Step 5 breaks the scale entirely. The observable universe, the portion of everything that light has physically had time to reach us from since the beginning, is measured at about 93 billion light-years across. That number should surprise you, because the universe itself is only about 13.8 billion years old, and simple math suggests a much smaller sphere. The gap exists because space itself has kept stretching for the entire time that light has been traveling toward us. Galaxies that emitted their light billions of years ago are no longer anywhere near where that old light suggests. Astronomers now estimate the true edge of the observable universe sits about 46.5 billion light-years away, in every direction, which means the space between here and that edge has effectively spread apart faster than light itself, without breaking a single law of physics, because it is space that is doing the stretching, not any object inside it. 93 billion light-years, wall to wall. Somewhere inside that sphere, on the suburban edge of one unremarkable galaxy, orbiting one unremarkable star, sits the room you started this episode sitting in. Here is the part actually worth sitting with, and it is not the part you are braced for. The expected reaction to everything you just heard is that you should feel insignificant. Room, city, country, planet, solar system, galaxy, universe, each step swallowing whole the one before it, until the zeros involved stop meaning anything to a brain that evolved to track a few hundred relationships and the nearest handful of threats. By any reasonable accounting, you should not register at all. But notice what actually just happened in the last few minutes. A small, ordinary arrangement of matter, sitting in a room, on a single grain of a single planet, just held a city, a country, a planet, a solar system whose true edge outruns our most distant machine, a galaxy of hundreds of billions of stars, and a universe, and understood exactly how each one nested inside the next. The universe did not do that math. You did. That is the actual finding here, not the smallness. Somewhere in the last few 100,000 years, a scattering of ordinary atoms organized itself well enough to build telescopes, launch a probe that is about to become the farthest thing our species has ever touched, agree on shared units of measurement across competing observatories on opposite sides of the planet, and sit patiently enough to calculate the size of a sphere it will never physically cross in its own lifetime. The universe is not impressive because you are tiny inside it. It is impressive because something this small, this brief, figured out how to measure it at all. None of the steps in this episode were guesses. Every rung on that ladder, the reach of the Kuiper belt, the true edge of the Oort cloud, the light day Voyager 1 is about to cross, the width of this galaxy, the width of the observable universe, came from an actual measurement, taken by an actual instrument, built by people who will never personally travel far enough to check any of it by eye. That is a strange kind of trust to place in a species. It is also an honest question worth leaving in the comments. Now that you have actually felt the distance between your room and the edge of everything, does it make you feel smaller, or does it make the plain fact that you exist, right now, doing the noticing, feel stranger and rarer than it did before you pressed play? There is no wrong answer. Most people are surprised by which one they actually land on. In the next episode, we reverse direction entirely. Instead of measuring how far outward everything goes, we go looking for 5 real, confirmed places inside the same universe where the ordinary conditions your body depends on, pressure, temperature, even gravity itself, stop being background and start behaving like a weapon aimed directly at you. You just measured how big the universe is. Next time, you find out exactly how much of it would like to kill you.